Alright, so what is that we will do today? First we'll try doing the log stuff that you wanted to clarify, and then we'll go to plotting graphs with inequalities. Okay. Now, when we talk about logarithms, the first thing that comes to mind is something to the base 10. When you say log of 20, default understanding is it is base 10. Okay? But log of any number or any variable, any constant, whatever you think about, by default it is assumed to be base of 10, but that is not a criteria for log. You can have log of any number with any base. So you can say, okay, find the log value of 600 with base 2. Okay. So before we go into logs, let's do a quick recap of what we know about exponents, because that will be of great help. If I say a to the power 3, simply means a into a into a. If I say a to the power 4 into a to the power 2, what we end up doing is, this means a to the power 4 plus 2. Yeah? I'm just doing a recap because this will come out handy actually. Okay? If I don't say anything, that's even better. So if I say 10 to the power 8 divided by 10 to the power 6, what we end up doing is 10 to the power 8 minus 6, that is 2. So be it 2 or be it 6, I am one bad teacher who doesn't care about answers. I care about the process. So if I know the process, I can solve hundreds of problems. Okay. So if I say a to the power 4, it's a to the power 4, a into a into a into a 4 times. Now if I say a to the power 2, I mean a into a. If I say a to the power 1 by 2, what do I mean? And this is still story, I'm not doing maths. Okay? I'm just trying to get you used to these things, okay? That's all. If I say 8 power 1 by 2.
8 times a by 2?
It, any power, if I say a to the power 2, that means a into a. If I say a to the power 1 by 2, what I mean is a to the power 2. So you'll see, basically this becomes like this 1 by 2 that you see here, this becomes reverse of this. Or you can say this as square root of a. Okay. I'm just getting used to it, don't worry about it. This is just a concept. Now, if I say, and first of all, what is meant by square root? 25, I can say, is 5 square. Okay? Or I can, if I do a square root of 25, that means something this is this. If I do this, that means a to the power 2 by 2. That becomes a to the power 1. So square root of anything. Now look at this way. 3 power 2 means 3 into 3. 3 to the power 1 by 2 means 1 by 3 into 3. Am I doing it right? No, I'm not doing it it right. This is not right. This is not right. Don't look at this, whatever I told you with the 1 by 2 thing, okay? But square root is fine. Let's do a recap. So anything to the power 3 means this into this into this. Anything to the power 1 by 3 means cube root of 1 by 3 is what? Cube root. Or if I say this, that means cube root of, square root. 2 is square, 1 by 2 is square root. 3 is cube, 1 by 3 is cube root. Okay? That's how it is. It's not 1 by this. So, now, what is that I was trying to tell you? Tell you only. So this, now, what is square root now? So, when I say 5 into 5, that is 5 square. If I say square root of 5 into 5, so if there is nothing written, that means it is called square root. Okay? If I put a 3, that means a cube root. If I put a 4, that is what is that called? 1/4, or basically reverse of to the power 4. Okay? Now, so if I say square root of this means you have to convert this into square, and if you want to take this thing out, whatever value you have here, this to the power 1 by 2. This is what it is. So now this will become 5 to the power 2 into 1 by 2. That is, you know this, right? I mean, if you have some power and to the power something, this is a multiplication. If you are multiplying two different numbers with the same base, you add the power. If you are dividing, you subtract the power. This part is clear, right? So now if we try relating this with the logs. So let's look at this. Log of 100, if I say. What this means is, if I'm not writing anything, that means I'm saying log of this. So this becomes so if I say log of 10 base 10, that is this value is 1. Log of anything log of any number to the base a to the base a, this will be 1. Any number with the same base will be 1. Okay? So basically what you end up doing here is, let's say if you are trying to derive log of 100 to the base 10, what you have to do is, you have to convert this into the power of 10. And this value turns out to be 2. So if it is 1, whatever is the power to this, that becomes your value. Now let's pick up one question from your sheet that you have given. Let's try doing some one by one, and then you will see probably whatever I am saying here, how that is relatable with the exponents concepts. Okay? So let's pick up the first one. See, I'm getting older now. My glasses don't help me much. At times I take out my glasses to see it better. Okay. So there are two things that you end up doing. One is called expanding a logarithm. Second is called condensing a logarithm. Okay. So when you say expanding something, this is what it means. Let's look at the first one. Log of u by v, okay, with the base 6. Okay. So here, this is u. Okay. Here, this is something similar to exponents like we have seen before. So if you are dividing, let's say 10 to the power 4 by 10 to the power 2, what you end up doing? You say 10 to the power 4 minus 2. Here, log of something, when you have numerator and denominator, what it means is you can break this as log of u minus log of v. Now you will say why or how. Look at this as a number. Okay. Now, like the exponents that we have seen before so far. In this case, what happens? 10 to the power 4 by 10 to the power 2. If let's say this was what? If we are trying to find log of, let's say, 36 by 6. Okay? I will not do this division here. What I will do is, okay, log of 6 by 36. So I can say this is as good as log of 36 by 6 divided by log of this. Yeah? Okay? So, log of 6 by 36, it is, I can write this as 6 to the power 2, log of 6 by 6 to the power 2, log of 6 by 6 to the power 1. Isn't it? Okay? So here,
Wait, wouldn't log of 6 to 6 be 1?
log of 6, so log of 6 for 6 is 6 I can always write as 6 to the power 1, right? That's what I'm saying.
Oh, okay.
Yeah. So, if you assume that there is no log that exists today, you are essentially talking about dividing 6 to the power 2 by 6 to the power 1. So, it be or okay. Now let me not complicate this. Let me put that in a much simpler way. Okay. So any log that you talk about with a base, that just tells you what is the power to that number. If I say log of 8 to the power 2 with the base 2, what does it mean? You have to convert this 8 into power of 2, okay, and this becomes 3. 3 becomes your answer. Okay, so you can think like, okay, this and this gets cancelled out, and whatever is this thing, that becomes your answer. Because log of 10 to the base 10 is, you can write this as 10 to the power 1 log of 10, so this becomes 1. If you say log of 100 with the base 10, this becomes, this says 10 to the power 2. So if you want to take out the log, the answer will be 2. So you have to convert the number for which you are trying to derive the log to as a power of the base. That is what it is. So now if you look at what we were trying to do was, the first one was log of u by v. So what it means is, here it's like exponents. So exponent of 6 to get the value of this, exponent of 6 to get the value of this. So this works exactly like exponents, like I was showing you before. It becomes log of u minus log of v. Because if this is 100, if this is, okay, I can prove it one more time here. Let's say it is 36, it is 6. Okay. So you will write this as log of 36 as in 6 power 2 by 6 power 1. So it will become log of 6, it becomes 6 to the power 2 minus 1. So log of 6 1. So this becomes 1. So, okay, let me go step by step. If you are doing this, ultimately any number for which you have to try the find out the log, that has to be derived as a power of the base. If you are trying to find log of 100 with this, you have to derive 100 as the power of this base. 100 will be 10 power 2, so log of 100 to with the power of 10, and whatever the power, that is your answer. So this is another way of representing it. In the logarithm gives you to represent a number as a power of another number, which is a base. So here, if you look at log 100 with a base 10, that means you are actually representing a number which is power of 10 to derive 100. So in terms of story, if I am saying log of if I have to write something as this, okay, if I know that b equals to a to the power, let's say, c. So if you want to convert this into get the value of the log, it will be, let's say, the b is a to the power c. So this becomes, your answer is c, because as per the concept of log says that what is the value of the number as a power of this. So let's do some simple maths. If I am trying to find out the value of this as with power as with base as 2, can you tell me what will be the answer for this? Just try relating it. We are trying to derive 8 as a power of 2. So 8 will be 2 to the power 3. 2 into 2 into 2. So the answer will be 3. Or you can say, you have to get to a stage where you can say 8 is equal to this. So when you see this and the exponent being matching, so you only look at the exponent and that is your answer. So if you have to find out, let's play with this little bit more. If you have log of 36, what will be the value of this? What you will do is, you will just put this as a power of this, and once you see this exponent's base and the log's base matching, then you only look at this power, and that is your answer. Okay. If you have to say log of 64, okay, first thing you will do is, you will say, okay, let me convert this into power of 4. 4 times 4 times 4 is 64. That is 4 cube. Now this log, the base of log and the base of exponent are matching, so I will only look at the power, and my answer is this. So log pretty much works like exponent. It's an extension of exponent, okay, where you try to convert any number as a power of the base. So all the logs that we deal with, they mostly talk about finding out the log value of, let's say, 100 with a power base of 10. Most of log tables are base of 10, but it doesn't restrict you and say that it has to be always 10. Now let's say I say find out the value of this. How much it will be?
Log 7.
So you will just convert this.
7 times
7 square is 49. So now I got this and this matching. So my answer is this part. Okay. If let's say log of 216. What will you do first? You'll always try converting the number for which we are trying to find out the log value into power of the base. Okay? 216 is 6 are 36 times 6 is 216. So it is actually 6 cube. Okay? So your answer will be, if you have to find out the value for this guy, your answer will be 3. You match this and this. So now, so far we are looking at numbers which are perfect squares or cubes. Okay, that is why it's easy. Somebody says find out log of 121 with base 6. 121 doesn't come in the table of 6 ever. So you'll not be able to find it. It will turn out to be maybe something like 6, maybe 36. Something like 6 to the power maybe 2.4. Okay. And that is why the answer for this will be 2.4. Okay, this is not a perfect whole, this is not a whole number. Okay, but 6 to the power something, 6 to be multiplied by 6 certain number of times, that will give you this value, 121. So this power, the power of something exponent cannot be always a whole number, it can be a fraction also, or decimal also, that's okay. So this is just the log conversion. Now let's come back to what I was telling. So what we have learned in the exponents is, if we try 2 to the power 4 by 2 to the power 2, this converts to 2 to the power 4 minus 2. Log also works the same way. So if somebody says find out this u by v, this was your first question. Before I try doing this, I just want to tell you that if I am trying to find 36 by 6, what I am doing here is log of 36 by 6. What I am doing here is 36, I am trying to find out the power. This numerator is the power of 6, denominator is the power of 6. Yeah? So that becomes log of 6 to the power 2 minus 1. Yeah? So this is log of 6 to the power 2 minus 1 is 1. That becomes 1. Correct? Now if you look at it a little differently, if you would have done this like, okay, log of 36, see this is division, so I can play with this. Since I am dealing with only with the power, right? So it's like exponent thing. I can do it like this also. I can do it like this. And you will find the same answer actually. Because this will give you log of 36 as in 6 square minus log of 6 this. See, this is exactly what we are doing here. Log of 6 to the power this will give you 2 minus this will give you 1. So this is exactly the answer is the same. So whatever I have told you so far, there is only one takeaway. All that I told you was trying to make you explain this. But in simple terms, if you want to kind of take away from what we have done so far, logs work exactly the same way as exponents. Because log deals with exponents. You convert any and every number as a power of the base. So that is nothing but exponent. This is what, if I am putting 2 to the power 8, this is what is exponent. Log also, if I am saying log 2, 16, I am doing nothing. I am trying to derive 16 as a base of 2, meaning how many powers of 2 gets me 16, and that is what is minus 10. Okay? Okay. So this is just understanding part. So only keep in mind that You will deal with logs the same way like you deal with exponents. Before we start solving the problems, let's look at the problems one by one. And probably that will make more sense. So first one was logs u by v. So if I am dividing, meaning if I am dividing exponents, what I do subtract. So I will just break this into this minus log of v by base 6. That is the first one. This is when you are expanding the log. Look at the second question. We'll do the same thing. And I will make you do some on the board. I will turn off the video so that you don't have to feature in the video. I just want you to be confidently doing it. Let's look at the second one. I'll randomly pick. Okay. Second one is log of a cube root. Okay. Now, what does it mean? Let me look at it differently. Meaning, how I can write this? When I said something to the power 1 by 2 means square root. Something to the power 1 by 3 means cube root. So this is nothing but, it is telling me this is power 1 by 3. Yeah. So far so good. So if I have a 3, that means it's talking about a cube root. This is what it is. Now remember, what is the question to the power? A1, okay, yeah. So here, I can also, now there is another concept of exponents. If you remember, something to the power a cube into a cube into a cube into a cube. If I am doing it, what I can do is a to the power 3, 4 times. I can do this, correct? Same thing. Whatever you have, something to the power this, you can also write this as, bring it as a multiplication of this and say this. Now you will say why. Let's take one example. This. So basically whatever is the power here, you can say this. If, let's say, if you are trying to find out log of 16 to the base, as a base, with a base 2, what I am doing is, I am converting 16 as a power of 2, right? That will be 2 into 2 into 2 into 2, that meaning 2 to the power 4. Yeah? What is the value of this guy? I can, this becomes 4. This guy becomes 4, right? Because this and this are matching now. So I'll just take this value. Or I can also say this equals 4 into log of 2. Do you see what I did? Whatever were my exponent, I can use as a multiple. Because now this will be what? Log 2 base 2 is 1 into 4. Here also this is giving me the same value 4. So basically whatever is my exponent, I can bring it to as a multiple and then rest is my same value. So if you are looking at this guy now, see next few sums that you will look at, it will make it more clear. So we are talking about expanding this as cube root of this, right? Now first thing is, when I say cube root of a variable or number, what it means is that to the power 1 by 3. Cube root is 1 by 3, square root is 1 by 2. So it's just the reverse of your square or cube. This is square. This is square root, or you can write this as this to the power 1 by 2. Yeah. So now we'll use the same thing here. So first of all, I'm just getting rid of all the unwanted operational things. Okay. So this cube root, I represented that in a simpler way. Now what I can do, I say, okay, this is my power. I can always write that as a multiple, like what we did with the log of 36 base 6, right? Or log of 16 base 2. I can always write this as done. So you just put that in a simpler form as a fraction, and then whatever you have as exponent, that becomes your multiple. Like what we did with that example we took for log of 16 base 2, right? Now let's pick up the next question. Now it has come to a point where we can start playing with this. Let's put the next question. Do you have your phone with you?
Yeah.
Take the next question out. Let's see. Let's pick up. Okay. While you pick up your phone, I am writing the question. Log of 7. Log of 5 to the power 4. Base 7. I'm not doing anything here. I have a simple looking number here. I have a simple looking base here. I have an exponent here. Whatever is my exponent, that becomes my multiple. 4 into log to 5. That's it. We just expanded it. So what I'll do is I'll turn off the video. I want you to do one more sum. I am kind of getting a sense that you are confident with this part. I'm not really worried, but in the level 4, let's pick up one sum from level 4 in the same thing, okay? And I will do it, but you will guide me how to do it. Okay. It is this. Tell me how would you want me to do it?
First, I would take out the x. So, I would distribute like the exponent to the x.
Okay.
So it's 3 plus 3.
3 plus 3.
Right. So.
Did not 3 plus 3.
So wouldn't you put 6 in front?
No, you'll put 6 in front, but this is not 3. This is not 3 plus 3. It is 3 into 3.
Oh yeah.
Because always stick to the basics. It becomes this.
Right.
So here, when I'm breaking the bracket, so I will still do it in a much, again, step in a simpler way. I will say that I don't know about this whole magic. Let me first simplify this. I will first try breaking the bracket. So, if I'm breaking the bracket, this becomes this into this, and this becomes how much? 1 into 3. Right? Yeah? So now I have a much simpler problem to deal with. So this becomes log of x to the power 9, y to the power 3. After this you can simply play with it, not a problem. Only thing, and this is a very normal mistake that happens. Because when you deal with exponents, we know that okay, when I'm multiplying something with the same base, I add the power. So it is very tempting to say that I will add here, but always be mindful of the bracket, and that reminds you that yes, you are actually doing it over and over again. So you are multiplying it, not adding. Okay? Yeah. So once you have got this, then it's a baby. You can play with it. This and then plus this. Yeah. Hello, yeah. Hey, Alex. So my cousin has come from California, so my nephew and niece. Yeah. Okay, so this part is clear now, right? This is level 4. So I'm assuming you should not be having any problem. But what I would suggest is, whatever you have in your question bank, this sheet, right? Just challenge yourself and try doing it once. And if you get stuck anywhere, I'm here. Okay? Yeah? This part, expanding is easy now, right? I'm assuming that you don't have any question, but before I go ahead with my assumption, let me know if you want to correct me. So now let's look at condensing something. Condensing the logarithm. And how does that work? Let's pick up a question. So expanding is one way of dealing with it. Condensing is just reverse of what we have done so far. So let's look at something like this. The first question. So when you are condensing it, what that means is you are getting rid of all the multipliers or anything. Okay, so basically you just try to write this as a log of something. So all these multiples or other things that you have, you just don't want them, or do reverse of what we have been doing so far. So you have a multiple, you are multiplying something by 6. That means this guy would have come from here. Yeah, same thing. You are changing the value. Just the reverse of that. Pick up the next question. Tell me what is the next question. Okay. Sorry, I'm bothering you. Now let's look at this. Second question. See, here you'll find that there is no calculation needed. You have to just think about it. We are doing minus. Minus is nothing but division. We are doing a plus. That is nothing but addition. We are doing multiplication. That is nothing but the power. So this becomes, yeah, simple. You want to pick up a question, do it by yourself. Okay, let me give you one so that I feel confident. Log of 2 plus log of 7 with a base 4. Look at this whole thing. Only word of caution is never ever overlook the base. If somebody is having a mischievous intent, they will trick you by putting a 10 here, and then you will get tempted to say, okay, this is plus, so this is multiplication, I'll do it. But then you might go wrong. So always just be careful with the base. As long as the base part is seen carefully, it's easy. Okay? Now, let's look at the next one. 2 log x base 8. Do you think we need to solve this? Do we? No. We don't need to, right? Yeah. You know this. It's multiplied, it's coming as a power. Now let's look at level 4. Okay. Let's look at this one. Log of x base 5 by 2 plus log of y base 5 by 2 plus log of z base 5 by 2. They call it level 4. I call it level 0. Yeah? You agree?
Yeah.
It's very simple, right? What you can do? It's simple. It's saying that 1 by 2 of log 5 plus log y, again 1 by 2 of this, plus 1 by 2 of log 5z. Yeah? I can take 1 by 2 common. Yeah? Then says log 5x plus log y plus log z. Yeah? This is plus. That is multiplying. Yeah? It's 1 by 2 of log 5x into y into z. Yeah? I don't like this 1 by 2. Yeah? So now tell me if you have any or smallest of the doubt about what we have learned with expanding or condensing a law. And you have to be honest. It's okay if I have to teach it one more time, I don't mind. Clear? Now, this part is clear. Take a quick break. We have to change gear. So the next thing that we are going to do is plotting graph with inequalities. Okay. So this is a graph that I am trying to plot. Let's say my equation is x plus y is less than 7. Okay. So we are trying to plot a graph with x plus y is less than 7. Okay. Do you know how to plot a graph with a equation, linear equation?
Yeah.
Kind of. Okay. But it's very simple. No big deal. Okay. If I were you, this is what I will always do. Whatever is there, I'll consider this as an equation, normal equation, without inequality. Okay. And then try plotting a graph. In this case, what do we do? First time, if you have to draw a line, okay, you just need 2 points, nothing else. You just need 2 points and you join them. That becomes a line. X. So what I'll do is, I'll try finding first point when x is 0. When x is 0, what is the value of y? 7. So when x is 0, x will be 0 on the y-axis. Y is 7. So let's say this is 1, 2, 3, 4, 5, 6 and this is 7. Okay. So this is my first point for this line. Okay. Next time what I will do? Next time what I will do? I'll make y 0. Because that is also satisfying the equation, right? When x is 0, y is 7. When y is 0, x is 7. This is my second point. So here is the difference. If I am drawing with an equation, meaning with this, I will bravely draw the solid line. If you are taking a note of that, you can take a note of that, that's fine. But you can minimize on the amount of note that you are taking because you anyways have everything in the video. So you can always use that. Okay? So here, what I am doing is, I will consider this as an equation, normal equation, and draw this line. When I am drawing the line, that is when I will get a little cautious. I will say, okay, no, it's not a normal equation, I am just playing with this. So I will not draw a solid line, I will draw a dotted line. So that I will decide what I want to do. Now, x plus y has to be less than 7. So, it will be either on this side of the line or this side of the line. Let's figure it out. If I pick any number below this, let's say I pick up this number. Okay? On this place, what is happening? X is what? 1, 2, 3, 4. Y is 0. X plus y is less than 7. So this side looks okay. Let's pick up another point somewhere here. Okay, not below this line, because we are checking whether this is representing this side of the line or this side of the line. If I pick up this point, this is what? 3 plus 2, 5. So this is 5 and 0. 5 and 0. So this is also less than 7. That means when I am talking about less than 7, we are talking about this side. This is the graph. So this is the. So when you are talking about inequality, it doesn't give you a line. It gives you a zone which will be satisfying this inequality. If this was this, your zone would have been this. So when you are drawing a graph with inequality, the only thing that you have to do is assume it's an equation, normal equation. Draw that dotted line and then pick any point, pick a simple point. Maybe you can pick a point on the y-axis, which is below this line, or x-axis, so that you don't have to do a lot of calculation. You can just put that value, one value as 0, other value as whatever number you are picking, and see if that is satisfying the condition or not. So once you get this one, that means it is below. If you find something here, let's say if it was x plus y is greater than 7, if I would have picked up this point, this is 3 and 0, this is 3 plus 0, this is not greater than 7, so this side is not correct. I have to pick up things above the line. So that is the inequality part. So if I have to do a recap of what we did here with this guy was that when you have to draw a zone with inequality, you treat that as a normal equation. Take your seat. You draw that with a normal equation and then find out which side of the line it will be, whether it will be above this or below this. Take a seat. Alright? That is the only judgment you have to do after you draw the dotted line. Alright? That is all we covered today. That brings us to the end of the class.